All right, let's get started. Thank you so much for being here. I want to talk about a little bit of agility and Java together. But before we get started, it's great to be here, and thank you so much for coming. How about a show of hands for the amazing organizers of this event and the crew? They put in a lot of effort, so I think they deserve the thank you from us. Thank you so much. Awesome. Thank you. I've learned a few things this weekend, but one thing that absolutely amazed me is being at CERN is I learned that they mastered the technology to take subatomic particles that you cannot even see and make them collide. But they're still having challenge connecting computer to the projector. That's what I found out yesterday. However, we are in great hands. They just didn't shrug and say, it's life in the big city and walk away. They put their heads together and they solved it. I am connecting from my own computer today. How cool is that? And I asked them, and we repeated it. We made it fail, we made it pass. They believe in repeatable process. So now that we were able to repeat it, I asked them, this is amazing. Can you tell me how you solved it? And they gave the best answer ever. They said it works. We don't have a clue why it works. So we'll just keep it that way. So it's great to be here, but I want to talk about something we all talk about every day. I go to companies and they tell me, oh, Venkat, you got to know, we are agile. And I always tell them, I'm so glad we got that out of the way. Let's talk about what you actually do. I've been writing code for about 35 years. And I realized something a few years ago. When I was a young programmer, we did waterfall development. And we called it waterfall development. Today, people do waterfall development, but they call it agile. Because that sounds so much better, isn't it? So that's a bit of a frustration. So I wanted to ask the question. I go to a lot of companies around the world. I do training, consulting, mentoring. And I kind of observed what people do, and I want to really distill what agile really means. And I think you will agree with me, right? So agile really means we need to have stand-up meetings. You're laughing, right? But why do we do stand-up meetings? The reason we do stand-up meetings is this is not a problem with you and me. This is a human trait. Humans love rituals. We love rituals. You know why? Because rituals give us relief from reality. You don't have to do the real stuff. Hey, can you fix this problem? I got a stand-up to go to. So that's amazing, isn't it? No, stand-up is not what Agile is about. Then what is it? Oh, I think I figured it out. It is about doing Scrum. No, not really. Well, actually, it's about velocity. That's what it's got to be. Because if we got good velocity, everything is done, isn't it? Well, it's frustrating because if I go really fast in the beginning, what does that mean? Maybe I'm doing the easy stuff. Maybe I'm ignoring quality. Hey, there's a one easy way to go faster. Don't write any test. That's the industry standard, isn't it? Well, that doesn't help us. So what is it really to be agile? I think I finally figured it out. It is really about hiring a Scrum Master. That's it. We fixed the problem now. I don't understand how this actually happened. This was never supposed to be a title or a job. This is the best way these are the smartest people, by the way, because they get paid to do nothing. This is best thing to do in life, right? So what is it then? Well, I have a problem. I have a little thread in my mind that keeps thinking about programming, software development all the time. That's just my problem. But I was having lunch with my family, my 2 kids on my side with my wife, and we were talking about something, and all of a sudden, I kind of took my phone and started typing something, and my 2 children kind of leaned over. That was a few years ago when they were a little smaller than they are now. And the kids immediately said, oh my gosh, Dad, please don't tweet that. And I kind of looked at it, and they said, no, you shouldn't tweet something like that. But of course, as a parent, I think you will understand your biggest mission in life is to always embarrass the children. And when they say no is when you really have to do it. But the minute I tweeted it, I was so shocked because that turned out to be one of my most infamous tweets ever. Within minutes, thousands of retweets, and they're like, oh my gosh, I cannot believe people are retweeting such a bad idea. Well, so here's what I tweeted. And I simply said that day, I've set the wedding date, I've not asked her out yet, how software projects are managed. This is one of the problems in the industry. You go to companies and they say, here is the deadline, first thing, right? As if that's the most important thing. And here's the scope. Oh, by the way, we are agile. What's there to be agile? If you have set the date and you have set the scope. So it makes no sense. I always say, this is like the guy who went to this lady and said, honey, we're going to get married. We're going to have 3 children. Here's where we're going to live. And here's where the kids are going to go to school, et cetera, et cetera, et cetera. And the lady's like, who the hell are you? That's kind of the way projects are being done, isn't it? That makes no sense whatsoever. So the question really is, what is really agile development? And it turns out, agile development is not about the process. It's not about using a certain technique or a tool or stand-up or velocity or having a Scrum Master. It is really coming down to these 3 words. And that really is coming down to feedback-driven development. So it really is feedback-driven development. Well, part of the reason for that is software exhibits what's called an observer effect. And the minute you develop a software, you can observe it. And way back in time when we did waterfall, we would design software for months on end. And then we would analyze it and design it. And eventually, we will come down to implementing it. And if you look at the timeline, and if you start designing and analyzing, and then here you start implementing the code. When you implement the code, something beautiful happens. You can compile it. And when you compile it, you can run it. And when you run it, you can complain about it. The problem with that is that feedback loop comes way late in the game. So on the timeline, when you realize what you're doing is not what you want, that moment is called a moment of panic. Because you're like, oh my gosh, are you kidding me? We're getting close to the deadline. How do we finish this? Well, what we are supposed to do in agile development is start early on with the implementation, not by ignoring the design, but doing enough of the design. So not a big upfront design, but just adequate enough design so we can start implementing and have feedback. Now, this reminds me of an experience. I'm talking about, maybe about 30 years ago. And my wife and I were on our very first trip to the Grand Canyon. You got to remember, these were the days before what we know as cell phones. And we both got together. We were young students back in time, got together in a car in Phoenix, started driving down to Grand Canyon. Well, the problem is, Grand Canyon is not a mountain. It's a hole on the ground. So you cannot see it from a distance. So we are driving through the deserts of Arizona, and nothing to be seen in sight. So after driving for an hour, I parked the car, get out, and ask the question, are we heading in the right direction? And the simple answer is, we don't know. And we could keep going for another hour for them to say, no, you're in the wrong direction. Or we could go back from where we came from, only for them to say, yep, you were in the right direction. So what do we do? And you may say, gosh, but didn't you have a map? Oh, sure, we had a map. We put the map on the hood, and we kept staring at it. But you know what that map did not have? Just one thing. Anyone guess? The blue circle. That's right. That blue circle is the only thing that was missing. Today, of course, you get in the car, we start driving. We did this yesterday. Let's go. Oh, that's the wrong direction. Let's go this way, right? And that's the feedback. What if you can have that blue circle on your project? I don't care where you have been. I want to know, where are you and how far are you from the finish line? And if you are going at the rate you want to, keep going. Otherwise, you make some changes. What's that called? adaptive planning. So adaptive planning becomes the essence of agile development. And if we are not being adaptive, then why bother using the word agile? And that's really what it comes down to. But when you see this in action, it's absolutely fun to watch it and see it evolve. That brings us to Java, and that's what I want to talk about. Java, I'm going to say, is agile, but that's not the way it was years ago. And I'll be absolutely honest about this. If you go to YouTube and look for some videos that I had, presenting talks back in 2010, 2008, 9 time frame, I was that guy on the picket line, constantly complaining, Java is no good. Things are not moving forward. Things are stagnated. I'm not exaggerating. I saved these for historic reasons. I used to get hate emails. The email said things very simply and short. It said, Venkat, I hate you because you hate Java. And obviously, people didn't like me talking about Java that way, but it deserved it, in my opinion, back then. However, all that changed, well, starting in Java 8, but more so a little later. However, if you look a little bit about what happened to Java, Java was moving at a snail's pace. And we often look at a language like Java as the language. But if you really think about it, Java is not one language in that sense. The initial developers of Java, most of them are no longer developing Java today. They have retired or they have moved on to other positions. It's a much younger generation, relatively speaking, of people who are spearheading the language today and moving it forward. So we often think about this language as one thing, but it's not the one thing that we are talking about. It's different groups of people who have been moving it. And there was a time when there was a period of transition. The language didn't know what direction to go to. The spirit of doldrum, and people like me didn't have anything better but to complain about it, until a new set of people came along and said, no, we got to really move Java forward. And they just didn't talk about it, but they did. However, when you look at the timeline, it's pretty amazing. Notice Java 1.0 was in 96. Java 1.1, 97. That's pretty good, isn't it? 1.2, 98. Then we have 1.3, 2000. Look at 5. That was 2004. 6 really didn't have any language features, as you know. That was 2 years later. And then there was a 4-year, is it 4 or 5 years difference? 5 years difference, isn't it? For Java 7. And then a 3-year difference between Java 8. And keep in mind, what was in Java 8 was supposed to be in Java 7. There was a time of discussion. Now, look at what's happening. It got slower and slower and slower. But why? The reason was simple. They would announce what will be in a version of Java before any line of code was written. And you know what that means, right? When you try to commit to a deadline before you even thought of implementation, how do you expect that to be, finishing? But then as they started implementing, a few developers would implement their features. We are done. Whoa, hang on a second. We can release it, because the release has to include all these features, so hang on a second, we'll get back to you. And they go to the developer who's working on the other feature and saying, hey, we got to make this release, it's time, how's it going? You and I know the answer for this, right? They are as much humans as you and I are. What do you tell your boss when the boss says, how's it going? And they said exactly the same thing, it's almost done. And it's almost done usually means 7 years later. And that is the problem. My wife nailed it the other day. She came to me and said, Venkat, you don't know this, but you need to know this because this is better for you to know in life. And she said, 5 minutes of programmer time is 7 hours in human time. And I didn't realize it, right? Because every time she says something, I'll be done in 5 minutes. 7 hours later, I'm like, looks like it's working. Right? And that's the problem we deal with is we got this, somewhat of an extended, vision of the time. For us, everything is happening really quickly because we see from the problem to solution with all the mess that's happening in between just disappears in our head. So the point really is this was not working for Java. And the problem really is that they were trying to plan ahead to what will be in a version before they could understand the realities. But the difference is they decided to take a very strong action about it. And that's what blows my mind. So if you look at Java 10 to 11 to 12 to 13, and as a clockwork, it's been every 6 months since then. This to me is an amazing opportunity for us to learn about what true agile development really means. This, by the way, it's important to keep in mind, was not easy. They just didn't wake up one morning and say, we're going to do this, and everybody said, great idea. And a lot of people said, this won't work. This is nonsense. Don't do this. And like everything else in life, people don't accept change until somebody takes the initiative, feels there is a reason to do it, has confidence in it, moves forward doing it, and the rest of us, like me, can stand here and appreciate what they have done. So this is an enormous accomplishment, in my opinion, but it's also a lesson they taught us on how we could do Agile. So in that regard, Java is now, of course, no longer moving at that snail pace. It is accelerating and moving forward really, really well, which is great for us, but it's really also important for us to understand a few things. You say, wait a minute, a 6 months release cycle. Is that even practical for us to release things in 6 months? That's a genuine question to ask because we become very nervous. And I've had people ask me, oh my gosh, what will be the quality of Java if they're making 6 month releases? Oh my gosh, they're going to be throwing half-baked solutions at us. And all these fallacies and fears are very common to anybody, so that's no exception to programmers as well. But I do want to make it clear, Java is not being developed on a 6 month cycle. I think this is where a lot of us get this agile development really wrong. Because when you go to a lot of companies, what do they tell us? They put us into a box and they say, you got a month-long sprint or you have a 2-week iteration. And we are struggling to get things under that time frame. Thankfully, that is not what people behind Java did. They didn't go to the team and said, we want to be agile. In fact, they never used the word we want to be agile, honestly. They didn't go to the team and say, we're going to be in a month-long sprint or a 2-week iteration. None of that. Java is not being developed on a 6 month cycle. How much time are they taking to develop a feature? The short answer is, however long it needs to be taken. If you take that one feature in Java 10, which is type inference, it probably takes you about 10 minutes to understand what type inference is, another 15 minutes to understand when not to use it, and then you kind of like, cool, this is something I can use. It took them 5 years to develop type inference. Why did it take them 5 years to develop type inference? Because there is enormous amount of complexity in there to not only get it right, but it also to do the right thing in terms of what type inference resolves to at the compiler level. So they took 5 years to develop that feature. If you look at the feature in Java 19 to 20, approximately, the concept of Project Loom Virtual Thread, they've been working on it for 12 years in the making. So it's not something they cook up in 6 months and say, here you go, let's release it. So they are taking the time it is necessary to develop the features. Not only that, remember that feedback-driven development. The features are being introduced as a preview feature. So we can get to use it, we can experiment with it, we can provide feedback, and then they can go back and change it. So as a result, features exist at least for 2 releases as a pre-release. An example of this in Java 12, if I'm not mistaken the version number, there was supposed to be raw string. People were talking about it, people were blogging about it, and about 3 weeks before the release, that feature was not to be found. They yanked it out. Well, the reason is, based on the feedback and comments they received and based on working through it, they found that there was a much bigger use case they were going after, and the current implementation simply wouldn't really make that happen. And as a result, they pulled it out, and then they reworked on it. And of course, we have text blocks as a feature that is much more amazing, and we can make use of them as well, as I'll get to in just a few minutes. So what is really important for us to understand is Java is not being developed on a 6-month cycle, but Java is being released in a 6-month cycle. But I'll relate to this with one example. I was turning 50 a few years ago, and right about as I was approaching my 50 years of age, this was back in 2018, I was on a train ride in Poland between Krakow and Toruń. I was going to go there to speak at the user group. And my wife was at home in Colorado, and it was about 5:30 in the morning as she was waking up. I was sending greetings to her, and then suddenly a thought came to my mind on this train. And I texted her this thought, hoping she would tell me, you are really, really crazy, get off the train. So I texted to her saying, hey, I just got an idea. What if I speak at 50 Java user groups to celebrate my 50th birthday? And she said, what a great idea. And the next thing, I tweet about it, and within minutes, I had like 18 user groups said, come over, talk. And by the time I was done putting a little blog together about it, I had 53 user groups that signed up for me to come and speak. And then I got an email from the Paris user group. Here's Jose and the group saying, hey, we are celebrating the Paris Java user group's 10th anniversary. We can celebrate your 50th birthday and our 10th anniversary at the same time if you're interested in coming to Paris. Of course, who would say no? And I didn't know at that time when I said yes, but it turned out that the talk was actually on the Eiffel Tower. And it was kind of a weird experience, though, I should say, because you kind of felt the building move a little bit as you're giving talk. It was not me speaking too loud, I can tell you that. But the point really is it was an amazing experience. And when we were said and done, I finished about 53 user group that year. No, I was not going to claim I was 53. Besides that, I still wanted to be 50 on that year. But in this idea of coming to different user groups, I got an email from the Switzerland group of user groups, and Marcus Filon, an amazing community leader here, said, I'm going to give you a chance to speak in 5 user groups in 5 days. You can knock that out of your calendar. And then we'll put you to Germany for speaking on the 6th day. So you do 6 user groups in one trip. I'm like, this is great. 6 days every night I speak, and I get 6 out of the 50 I wanted to cover. But I was very nervous because every time I travel, I'm like, oh my gosh, what if there's a flight delay? What if I miss a bus? What if I miss a train? What if? Well, I land in Zurich, and he comes and meets me at the airport, and he literally hands me a little folder and says, here is your ticket to go from one city to another. And all you have to do is show up at the user group about an hour before your talk. The tickets are valid the entire day. Swiss trains are very punctual. You got a train every 20 minutes. And you can take the train any time in the day you want to. And I would wake up in the morning in a city. I would do some work for a few hours, go for jogging, have a nice breakfast, and decide that I really need to go to this other city. I'll go to the train station, have a small talk with somebody. I've never been ever so relaxed ever when I travel. And I traveled for 6 days continuously, but never felt more relaxed. But why? Because there was a train every 20 minutes. I have one flight tomorrow morning, and I cannot even tell you how many times I've checked the schedule. And I've been worried about it because if I miss it, not a bad place to stay around. I'm not complaining, but I would rather go home rather than be here. Not because this is not a great place. It's because I really want to be home as well. But the point is, when you have a train every 20 minutes, what is the cost of failure? The cost of failure is minimum. If I cannot take this train, I can take the one in next 20 minutes, not a big deal. And so now the Java train is leaving every 6 months. If your feature is ready, you want to get it out for a pre-release or a release, you can release it in March, or you can release it in September. So you don't have the pressure of having to release something quickly. You also don't have the pressure of delaying a release because somebody is not ready yet for a good reason. And this really contributes to better quality, and to me, that is what really agility is all about. So that train that we can keep taking and we can be on time is just absolutely amazing. I really wish more countries had trains like yours, and more, and of course, when I'm in Switzerland, people still complain about their trains, but that's just human nature, right? It's okay, but complaining is all right, but there's only a degree of complaint, right? You complain about train occasionally being late. I complain about not even having trains, because I live in a part of a country where you have a car, you can go out. If you don't, you can sit where you are, right? So that's the nature of the world we live in, unfortunately. But what this kind of relates back to is Java is not being developed on a 6-month cycle. Java is being released on a 6-month cycle. This makes a huge difference, in my opinion, about what true agility really is. Because agility is to be able to keep moving at a constant pace at a very long time. In fact, I would argue sprint is the worst word to use when it comes to agile development. You want to be in a marathon, not a sprint. Somebody who is sprinting is going to pant after they sprint. Oh my God, I cannot do this anymore. Give me a break. Well, you want sustainability when it comes to agile development. So you want to do the right kind of things so you can keep creating this over time. That becomes really important, and keep moving forward. So this experience of releasing incrementally by the team, and I give the credit for them to embrace this idea, has led to several amazing things that we have been given this incremental releases. Much like the steps, I go hiking quite a bit. I live in Colorado. I love hiking. But one of the things you do when you hike is, unless you are a super Olympic athlete, is you don't try to climb up straight. You're going through switchbacks so that it becomes easy on your body and you can sustain. Where I live, I apologize because we are still using barbaric units of measure. Our mountains are at 14,000 feet. Converting that to meters, I will leave that to you. But that's a lot of height. So essentially, you can't really go through that much height. We typically hike for about 7 or 8 hours to go up and then come down for the rest of the day, and you have to have the switchbacks. In a similar way, by giving this incremental release, the language has been progressing steadily over time. But this is the beauty of how the language has been evolving. Now, I'm not bad-mouthing any language right now, but there are some languages where they have the luxury that Java will never have that luxury. Those language developers, the developers of the language, have the luxury to really change things any way they want to. They say, whoa, it wouldn't be cool to change all this in the next release. And they make drastic changes. And they have a small group of highly passionate programmers. They get excited. Whoa, this is amazing. We can change all our code in the next release. That's not a luxury that Java has, because Java is being used by more than 10 million programmers. Java is being used in billions of devices. If you make a change that's not backward compatible, that's going to be a disaster. But the problem with backward compatibility is this. If you favor backward compatibility, you're doomed. If you don't favor backward compatibility, you're still doomed. So your choice, which way you want to be doomed. And Java decided to really work extra hard to provide the backward compatibility, but Java doesn't have the luxury of saying, here is a feature, go use it, and then saying, oops, we didn't do a good job, let's try this again differently. Why? Why can't they do stuff and change it drastically? The reason is very simple. As I said, Java is being used by 10 million programmers. And I think you will appreciate the fact that if what you create is being used by 10 million people, and out of which 1 million people know where you live, you have to make decisions very differently. And that is one of the problems why Java has to really favor stability. So in order to provide it, They are not run by infatuation. That is something very important to keep in mind. They're not waking up in the morning and asking the question, "Ooh, look at that. That language has this feature. Wonder if we can do that too." Definitely not the case. Instead, they are going through a very rigorous process, and they're looking at 3 different things in evaluating if a feature should be in the language or not. The first thing they are looking for is this really useful for Java programmers? That is one of the most important things we want to consider. You don't want to do things that feel it's cool. You want to do things that are of value to your users. So the very first thing they're asking is this feature useful for Java programmers? The second question they're asking is, if it is really useful, it's going to give them the benefit. The second question is this feasible to do within a reasonable amount of time and cost? So usefulness and feasibility is the second question. If it is feasible, then they ask a third, even more difficult question. If we introduce this feature, what's going to become harder in the future? Because there are times when you implement a certain solution and then it captures you on the other side and you're like, oops, we can't do this easily because that one we did back in time is not compatible with this or makes it harder. If you really think about it, there are features in Java that you are introducing, but you want to make sure they all come together and work together. That is really, really hard. And I hate to use this word, but when you and I work in software, your boss or your business analyst comes to you and says, "Hey, can we make this change?" We're like, "Oh no, I don't think we want to make the change. Why not?" And you're like, "This code has been written for a long time, right? And this is a legacy code." And Java is the biggest legacy code. And I'm not saying this in a bad way, right? We got this notion of, oh, legacy code, don't touch it. But they are sitting on the top of legacy code. But the case in point, I was with a client not too long ago, and I saw them that they have to make a change, and when we were talking about it, literally their face went red. Because when I mentioned a certain restriction in the code, they all looked at me and said, "Whoa, that restriction is going to be really hard. Is that true?" was the first question. I demoed the restriction to them, and they were in a bit of a panic. They said, "We thought we could make all this change next week. But looking at this restriction," and they had like 7,000 jar files. I mean, when I say 7,000 jar files, it's they're making their own jar files. And it's a large system. And they looked at me and said, "Do you realize this is going to take us 11 months to make the change? Not just a week." And I'm like, "Yeah." And then the architect was sitting next to me. I looked at the architect and said, "Why did you guys design the software that way?" And he gave the best answer that you always hear from people, right? When I said, "Why did you guys design the software this way?" He said, "Venkat, you got to know this. This was done before I joined the company," right? This is a very common answer. I'm the victim here, you should know this, right? So this was done before I joined the company. I immediately tweeted that day, I said, technical debt is the gift you give to the future developers, right? So technical debt is a gift you give to the future developers because somebody who don't even know who you are is messing with your code. And I realized this. As I was getting older, I would feel a little pain here, like, "Oop, that hurts over there," right? And I'm like, "Oh, that hurts over here." And I thought this was just me getting older. Then somebody reminded me it's not related to the age. It's related to the code I've written. I think somebody has a voodoo of Venkat. And the code I wrote in the past, somebody, poor young developers maintaining it, they don't know who wrote it. And they're like, every time they see a bad code, they're twisting the arms like, "Ooh, what's going on here," right? That's feedback loop right there. But the point really is that when you look at legacy, the changes you make become harder and harder the bigger the system, the longer the system has been. but they've been doing a remarkable job in evolving it. Let's take a look at just a few things to get a feel for what that is. For example, let's say I want to create a greet function right here. I'm going to say CERN right there. We want to create a greet function. So what should I do? I'm going to say public static, let's say string a greet. And let's go ahead and take the name as a string right here, if you will. And in this case, I want to say return a message, right? So what's this message? Let's say go ahead and say string message is equal to hello. Let's start with that really quickly. So here's a little message that's called hello. But what do I want to do? I'm going to say message plus equal to, I'm going to say how are you? And I'm going to then say message plus equal to thanks for, let's say, being here. So I'm going to say little messages like this, and I can run the code, and you can see the output. But we all have written code like this before. But sorry about that. Somebody's sneezing already. I know that's a great built-in mechanism, right? You sneeze when you see bad code, right? That is that kind of synthetic, analysis is great. Whatever you're taking, keep taking it. So the point really is, I mean, honestly, would you put that on your resume? Would you say, I've got 17 years of using plus equals? I don't think so, right? This is not the code you will go show mom and say, Mom, look what I wrote today. And mom is shaking the head. Kid, I hope one day you grow up, right? You can't show this to the previous generation because they're too smart to know this. What about the younger generation? You wouldn't show this to your kids. I mean, some of us work from home. If a kid runs into the room, you got 10 seconds to close your monitor. Imagine what's going to happen if a kid sees it. I really wish they had told me this when I was younger. People ask me, do you have children? I say, oh, I've got 2 children. The next immediate question is, are they programmers? And I got to tell you, this is a sad story. You are seeing the last Subramaniam who will ever be a programmer for next several generations. The reason is my children knew how terrible my code is. And I really wish somebody had told me this, but I would go for my trips, I would be sitting and working at home, a little kid comes around, I'll take my son, put it on my lap, I'll be coding. And what do little children know? I'm coding and the kid is kind of sitting and watching, bangs on the keyboard, occasionally that's a great variable name, I use it, and then you keep coding. And one day, while this went on, I suddenly heard my son say, and I said, oh my gosh, are you okay? And he looked at the computer, looked at me, looked at the computer, looked at me and said, is everything okay? And I said, Dad? I said, yeah. He said, don't worry about it. I'll grow up and take care of you one day. You don't have to do this anymore. And that's what happens when we write bad code. They never want to take after our profession, right? This is ceremony, this is noise, this is a bit of code we never want to write. But thankfully, we don't have to do that. So we can go back to this code. We can only do better. We can simply say, hey, here, I want to start by saying, this is basically a text block. Some languages call this as here docs, but Java calls it text blocks for a really good reason. And it's a lot more superior than what you may see in other languages as well. So that becomes a lot less ceremonious, and you can even, and this is only going to improve as time goes on, but you can go back to this and say formatted, and you can pretty much take this in here and provide a name, if you will, to provide for that as well. And so as a result, all that noise and all that ceremony simply goes away. But I've used here docs in other languages. But this is far superior because in other languages, as good as it is and it works, there are times I would waste 5 to 10, 15 minutes of my life because something just would not work. Whereas here, this was done very sensibly. Sensible indentation in the code as well. As you may notice, those indentations were ignored because the language is smart enough knowing how we will write the code and drops those automatically for us. So that becomes a lot easier to work with. But every step of the way, things are incrementally getting better. For example, if I were to take this and say process, and the process function, let's call this as object right here, maybe this is some kind of a message we are receiving, and I want to say this is the process, and I want to send to this maybe a value of 1. Or I want to send a value of hello to this. Maybe what I want to do here is I want to simply say something along the lines of if. We could say input is an instance of integer, and I could simply say return, in this case, got a number. So that's good enough for now. Otherwise, we'll say return whatever. We'll come back to that in just a minute. So if I run this code, it says got a number and whatever, but what about the string? I could say if input is an instance of string, I could simply return from here, got a string. So far, so good, isn't it? So at this point, of course, I'm going to say got a string of length, and I'm going to say plus, I'm going to say input.length. Will this code compile? No. As an experienced programmer, you know it will not compile. Well, if I try to compile this, it tells me that input length is not a property, not a method on object. So what do? You say, and you go back to this code and say string stir equal to, and then you're going to say string, and then this is the input, and then you can come back here and say stir, and you run the code, and it says of length. Anyone remembers what this feature is called? It's called casting. They call it casting. I call it punishment. So this is what it is. Why are we doing this? Now, imagine, how would you feel working with somebody like this? You are walking into the building, you saw them leave the building in the evening, you say, how's it going? And they tell you, I'm going to finally go watch that movie I haven't had a chance to watch. You said, oh, fantastic, have a good time. And they go away. The next morning, you meet them at breakfast, and you go to them and say, hey, did you go to the movie? They say, yes, I did. And you say, how was it? And they ask you, how was what? You're going to say, never mind, and you're going to walk away, isn't it? Now, what did Java do? Hey, Java, yeah? Is it a string? Yes. What's the length of what? And you're like, really? You're going to do this to me? So the question you want to ask is, do you work for the compiler, or does the compiler work for you? In the case of Java, unfortunately, in the past, you were working for the compiler. It comes to, how's it going? I'm working hard. Not good enough. Keep writing code. I'll see you after lunch. Right? But we don't have to do this. This is not the way a compiler should work with us. So what if we go back to this code, get rid of that, and simply say stir, and of course, you're going to use the stir right here. I like to call this as smart casting, because that's what Groovy and Kotlin calls it. But this is a good reason they call it as a pattern matching with instance of, because it leads to pattern matching facility, if you will. But the point really is that every step of the way, we've been getting these little incremental changes, and I merely scratch the surface over here. Then we have pattern matching. Then we have, of course, records and sealed classes, and not just those features, but how they come together and synergistically work together to provide the feature. And not even to mention the concept of virtual threads. So with virtual threads, of course, we are able to do asynchronous programming in a very elegant way without having to write a lot of code changes. And to me, the way I look at virtual thread is I see it as an aspect-oriented programming. Let me explain what I mean by that. When you are using an executor service in your code, you don't have to mess with that code. Way back where you're creating the executor service, you can tell the executor service, don't create a regular pool of threads. Instead, create me a virtual thread executor service, and you don't have to touch this code at all. So I see this as an aspect, if you will, because you can make a strategic decision as to what kind of thread to use, but tactically you don't have to make a change to your code. This is super powerful in terms of how you can make changes to your code minimally, but get a super giant benefit. Not only the code is simpler to write, you got better scalability, it is better on the environment, it costs less because you don't need as many machines on the services, on the Elastic services for scale, so there's a lot of benefits that come together. So overall, incrementally, we have been gaining on this over and over and over. So many talk about doing Agile. That's a really bad idea. It is about being Agile. So don't do Agile, be Agile. And if you want to learn a lesson as to how to do it, don't listen to people like me who talk about it, but look at the people who are actually doing it. And to me, that is a great example. Java is not just a great language, but a great ecosystem. But they've also shown how to do things terribly and how to change that and do it really well as well. What better learning experience than that? It's very refreshing to see this. It's amazing to see the evolution of Java. Hope that was useful. Thank you for being here. Thank you so much.